Welcome back to Subject Science. Today in this tutorial, we will discuss about rock-forming minerals, physical and optical properties. In the previous section, we have seen uh, about quartz part 1. This is part 2, rock-forming mineral, physical and optical property. That is Plagioclase. Okay, please like, share, comment, subscribe this channel. If you have a comment, if you have a question, please write on comment and give your feedback about this channel and for tutorials. So we'll continue about Plagioclase. Okay, Plagioclase is it is a basic rock-forming minerals from what? From feldspar group. So we will discuss about Plagioclase physical and optical property briefly. Let us continue. Okay, Plagioclase is a significant and widespread group of minerals within the feldspar family. Okay, simply, Plagioclase is a feldspar group, which is a major component of what? The Earth's crust. It is what? The major component of what? The Earth's crust. It is characterized by its distinctive composition, primarily consists of aluminum, silicon, and oxygen. This chemical composition, okay, with additional incorporation or impurity of sodium and calcium element. So plagioclase is a high temperature crystallized mineral in continuous series in the Bonds reaction series. Okay, in Bonds reaction series there are two groups, discontinuous and continuous series. In continuous series, plagioclase is formed in high temperature calcium rich, that's anorthite, and in low temperature sodium rich plagioclase is formed. So the main components or chemical compositions of plagioclase is aluminum, silicon, and oxygen with additional what? Sodium and calcium elements. Okay, in a Bonds reaction series, what I have discussed, we have discussed in this section. So this is discontinuous series. This one is what? Continuous series in during magma crystallization. So calcium rich we call as what? Anorthite, and sodium rich we call as albite. So this part is what? Plagioclase at high temperature, parallel to what? Olivine formed what? Calcium rich plagioclase we call as what? Anorthite. Albite is rich in sodium, while anorthite is rich in what? Calcium. So the difference between anorthite and albite plagioclase is that what? Albite is formed at the low temperature relative to what? So calcium rich, that's the anorthite. So their difference is what? Their chemical composition and the temperature where they formed. Albite at low temperature, whereas anorthite is high temperature relative to what? Other minerals. So the composition of plagioclase mineral range between those two end member. Two end member means that is the calcium and sodium rich end member creating continuum of intermediate composition. So albite and anorthite is a group of plagioclase minerals that their difference is temperature and chemical composition. Anorthite is calcium rich, whereas albite is what? Sodium rich and formed at low temperature relative to what? Albite relative to anorthite. Okay. So if you discuss about the general definitions of plagioclase, so we can discuss about the physical properties of plagioclase. Okay, plagioclase is a group of feldspar minerals that share similar physical properties. Okay? Here are some of the key physical properties of plagioclase. Plagioclase minerals have share of what? Similar physical property. The first one, color. Plagioclase can range in color from white to gray, green, or shade of blue. The specific color depends on mineral composition and impurity. So the color of plagioclase is most of the time what? White to gray. Due to what? Impurity. During magma fractionation, there is an impurity from the country rock. Due to that, the color of plagioclase vary because of the impurity present during the magma fractionation. Let us see in figure. So this is on what? Plagioclase. This is sodium rich and this one is what? Calcium rich. Calcium rich plagioclase is more what? Gray to gray green or blue. Most of the time calcium rich plagioclase is what? Gray green, green, gray and blue. Because calcium-rich plagioclase is formed at high temperature and most of the magma in that high temperature is what? Iron magnesium rich magma. That iron and magnesium rich magma cause impurity in what? Calcium plagioclase or anorthite fractionation. So the impurity most of the time what? Ferromagnesium minerals. That is magnesium and iron. Due to that impurity, the calcium plagioclase becomes what? Dirty color or becomes what? Gray or black relative to blue and green. Uh, when we come to what? Sodium plagioclase, when magma crystallized, the ferromagnesium minerals is crystallized and it remains out from what? The melt. Then the magma becomes more filthy. Okay? It becomes more filthy and it is rich in sodium composition or silicate element is composed in melt. Due to that, feldspar that sodium plagioclase becomes what? White in color. Okay, white relative to calcium rich plagioclase that is anorthite. Okay, streak. So color is depends on its impurity. Okay, streak of the plagioclase is most of the time white. Streak means the color of the powder when scratched with what? A plate, streak plate. That color we call as what? Streak. So the streak of the plagioclase is white. This is the diagnostic feature. So we have seen this. If the plagioclase mineral scratch with the plate, streak plate, this color, this line is a streak color. So this is white. The color or the streak of plagioclase is white. This is the diagnostic feature of plagioclase. Third physical properties of plagioclase is what? Luster. The plagioclase exhibit vitreous or glassy to purely luster. Okay, most of the time the plagioclase have vitreous or glassy luster. Lusters of what? Plagioclase. When the light is not transmitted. Okay? The fourth, transparency. The transparency of plagioclase mineral vary, but they are typically translucent to opaque. So, if opaque due to what? Impurity, translucent when the impurity is absent, or impurity, absence of impurity, the transparency of plagioclase becomes what? Translucent. So, two types of transparency. Opaque due to impurity, whereas translucent, the absence of impurity, or pure plagioclase. That shows translucent transparency. And this is the basic criteria for plagioclase minerals, that is a crystal system. Plagioclase crystallized in the triclinic crystal system. Most of the plagioclase minerals is grouped in triclinic crystal system, and it is crystallized often have prismatic or tabular forms. Okay, most of the crystal systems of plagioclase grouped in what triclinic crystal system, and it is crystal often what prismatic or tabular form. Okay, so we should know the crystal systems of Plagioclase. The sixth physical property, that is the basic one, is cleavage. The Plagioclase has good cleavage in two directions at approximately 90 degrees. Two good cleavage. Plagioclase have cleavage that is approximately cross each other at 90 degree, forming nearly right angle prism. Okay, this cleavage significant characteristic used in what identifying the mineral plagioclase. So plagioclase have uh, two sheets of two good sheets of cleavage at 90 degree. This is approximately like this. Okay, this one, this is the vertical one, this line we have seen is, and also this one is a cleavage, or this one and this one approximately cross each other at 90 degree. So plagioclase have two sheets of cleavage at 90 degree. This is the diagnostic features of plagioclase. So hardness in Mohs scale, the hardness of the plagioclase is 6 in Mohs scale. So this one is checked by what? Strict plate. So the common, most of the plagioclase group is what? 6 out to what? 6.5. This is equal as the basic criteria or the diagnostic feature for plagioclase is hardness, and it is 6 and 6.5 in Mohs hardness scale. The eighth physical property, that is the specific gravity. The specific gravity of plagioclase mineral range from approximately, this one is 2.6 out to 2.8, depend on what? Specific composition, depends on their composition, weight of the composition, and also the impurity. The specific gravity of plagioclase is range from this point to this. Okay, so we have seen the physical properties of plagioclase. It is color, cleavage, hardness, specific gravity, cleavage. These are the diagnostic features of plagioclase we have identified using in hand specimen. In hand specimen, plagioclase determined using this physical property. The diagnostic feature is a color, most of the time white to blue or gray. It have two sheets of cleavage at 90 degree, and it has white streak color, white streak. The streak of the plagioclase is white, and it's also its specific gravity. The hardness is 6 up to 6.5. This is the diagnostic feature we have determined using hand specimen during in the field or in the laboratory. We can determine plagioclase from other mineral, depends on this physical property. So the second most and more accurate identifications of optical identifications of plagioclase is optical property. Mineral can be determined in three ways: using physical property, using optical property, or the third one is geochemistry. Physical property using hand specimen, optical property of mineral determined using a microscope, and the geochemistry is very accurate, and it is what? Expensive to do to identify a mineral using geochemistry. It is expensive. So knowing a physical property briefly is very important to identify it in the field. In the field, the only material or the only property used to determine mineral or rock or other matters on the earth crust is physical property. Knowing physical property of mineral is essential and very important for geologists and for other scientists to determine types of rock, minerals, or ores. So knowing physical properties, the first aid. The second one is optical. If we are confused in the field to characterize or to determine what mineral is it, what mineral is this sample, or what mineral that taken sample is using optical property by making it in section and determine optical property. And if we are also confused in optical property, we can make we can prepare what geochemistry. Geochemistry is the final accurate identifications of minerals or rock to determine its. So the second and the most and the second properties of mineral to determine its name is optical property. So we have seen the optical properties of plagioclase. The optical properties of plagioclase minerals are significant for their identification and classification. To classify and identify plagioclase mineral, it is whether it is anorthite or whether it is albite, which is the using what optical property. Here are some key optical properties of plagioclase. Okay, so to determine optical property, first we have now the optical property of mineral generally. What are the optical property? I have a video in my YouTube channel like that is in Subgeoscience. In this YouTube channel, I have make a tutorial on optical properties of minerals. Okay, if you have confused on this tutorial, you should go in Subgeoscience and search optical properties of mineral. I have done using in Amharic. You have seen that part to know the optical, what are the optical property and what are its characteristics. So in this tutorial, I only show the optical property of plagioclase. I can't determine what are the optical property in specific way. If you are confused, please write in comment and I will uh, make a tutorial in brief way about the optical properties of minerals. So we have now the first optical properties of plagioclase. This is pleocroism. Pleocroism is the phenomena where minerals show different color when viewed from different crystallographic direction. Okay, pleocroism means changing color when rotating the microscope and arrange it in plane polarized light. If the mineral show changing color, that we call as what? Pleocroism. So plagioclase exhibit weak pleocroism, especially in shade of pale yellow, green, or blue. So pure plagioclase have no pleocroism. If it becomes impurity in plagioclase, it shows what? Pale yellow, green, or blue. In what? Rotating the microscope uh, by arranging PPL, there is changing color in plagioclase minerals. Okay, so plagioclase is weak pleocroism in optical property. Interference color. Well, the second most important determining the optical properties of plagioclase is interference color. When viewed under petrographic microscope with cross-polarized or PPL, plagioclase mineral cross-polarized in cross-polarized plagioclase mineral display characteristic interference color due to what? Birefringence. The color observed can aid in determining the specific composition of what? Plagioclase. Okay, it shows also interference color. So this is the basic and the most important optical property to determine what? The optical property of or to determine plagioclase in using microscope or in optical property. This is one is tuning. Is a common feature in plagioclase mineral, and it is often observed under the microscope. There are three common tuning. So plagioclase show tuning in microscope. Tuning is observed in cross-polarized light when the microscope is arranged in cross-polarized. When analyzer is in, if the analyzer is out, it is plane polarized. If the analyzer is in or work, it is cross-polarized. So tuning is the main characteristics or the diagnostic features of plagioclase. So there are three types of tuning in feldspar mineral group. The first one is Carlsbad tuning. Carlsbad tuning occurs when two parts of the crystals are oriented at an angle of 90 degrees to each other, also along one specific crystallographic axis. So Carlsbad tuning means it shows what? The tuning are in two parts at 90 degrees. Okay? Two parts of tuning map. We have seen this one. So Carlsbad means this. You have seen this line, okay? This line in figure, this one, this line. This is white, this is black, and this is what? Tuning direction. So this, if we measure this one and this one, it becomes what? Around 90 degrees. This one in microscope, this one, okay? This we call as what? Carlsbad tuning. It means a tuning that shows at 90 degree two seats, okay? This we call as what? Carlsbad tuning. The second one is polysynthetic tuning. Refers to specific types of tuning where repeated thin lamina or layers are formed in crystal along a particular set of crystal of right plate. This polysynthetic tuning is very common in plagioclase mineral. We have seen in this figure. This one is polysynthetic, repeating so what? Laminar or lines layers like this. This is black, white, black, white, black, white, black, white. This is repeating of black, white, black, white. This is called as a polysynthetic tuning. Okay. Cross-hatch tuning is also common. Two types. We have seen this one: Carlsbad tuning and polysynthetic tuning. Carlsbad and polysynthetic tuning is common observed in plagioclase. Now, these types of this cross-hatch tuning is common in feldspar or in orthoclase or in microcline. So feldspar, there are three types of tuning: Carlsbad tuning, polysynthetic tuning, and cross-hatch tuning. This cross-hatch tuning is what? Cross each other, okay? Like this one. At 90 degree cross to each other. Okay, this one. Have you seen? This one. This we call as what? Cross-hatch tuning in feldspar. Okay. The four important optical properties of plagioclase equal as what? Extinction angle. Plagioclase mineral exhibit an extinction angle, which is an angle between trace of the cleavage plane and the extinction direction. Extinction means black where rotating stage the stage of the microscope, the mineral grain becomes black. In which direction? Depends on what? The y and the x axis, the cross wire in the microscope. So it's this one becomes what? This one parallel to this one is what? Inclined extinction. Have you seen? This one is inclined. This one is also black. If we rotate these mineral grains, it becomes quite parallel to. Have you seen here? If you rotate here, it becomes white parallel. So this extinction angle is what? Inclined. Inclined means inclined or in the quadrant. Between quadrant, if the mineral grain become black between quadrant, we call as what? Inclined extinction. When it becomes black parallel to the y or the x-axis, it becomes what? Not inclined, parallel extinction. So extinction depends on the cross wire, okay? Depends. This is simple. Is it black between the within the quadrant around here, here, or here, or here? It becomes inclined. It is parallel to the x or the y axis. It becomes what? Parallel extinction. This is simple, okay? So thus optical properties are essential tool for petrologists and mineralogists when analyzing thin sections of rock under a microscope. So optical property is very important to determine the minerals identification within the laboratory. It becomes more accurate to name the mineral or to name the rock, depends on their optical property. Before determining the mineral's optical property, we should know types of what? Optical property in minerals or in rocks. The combination of this property helps in the accurate identification and classification of plagioclase mineral or other minerals, and contribute to our understanding of what? The geological process and the geological process that forms rock containing this mineral. So determining the minerals or using the optical properties important for knowing the geological process that forms rocks containing these minerals. Okay, if the rock that contain plagioclase or calcium-rich plagioclase, that rock is formed at high temperature, and if the rock that contain albite or sodium-rich plagioclase, that rock is formed what? At low temperature relative to what? Calcium-rich plagioclase in Bond's reactions rates. So the knowing the optical property and determine its accurate identification and classifications of minerals is important for what? Knowing the geological process that forms rock containing these minerals. Okay.